Alright, should be streaming. So this is a draftphysics.com, debatephysics.com also, video presentation and such. I think it's live. We'll find out very shortly. Yeah, there it is. And so, this Val, whatever he is, Rousseau, he's claiming this stupid video he did with a little propeller car proves kinetic energy when he never collected any of the car's energy. So he just calculated its energy. He didn't demonstrate that it has it. And so my simple counter argument is why not just crash it into a ballistic pendulum? And then we'll see how much energy it has. So just crash it into something bigger and heavier, okay, and have it stick inelastically, and prove your point, prove your physics. But he doesn't do that. And he claims that the energy is uncollectible, which is just a funny thing to state. For a physicist to say you can't collect energy, I think is pretty hilarious. But anyway. So I will be talking about the ballistic pendulum. I just posted a video on that subject because the other guy, it's just, it's too hard to have these conversations. You have to go through, you make a simple premise and they just won't follow through on the premise. And, so you say something like electric motors do not require 5 times the wattage to spin 5 times as fast. It just doesn't happen, and they won't concede the point. They'll just keep talking around the subject, and they won't show you any evidence that it actually does happen. And it's really frustrating, frankly. So that's the circumstance. Now, this Val guy, so not only does he post my real name, which is really bullshit. I don't publish under my real name. It's just a way of harassing people in America. It's just a fact that you don't want you don't want, especially if you're going to say anything controversial, you don't need your security put at risk. Okay, so again, this is just a tactic they use to harass. Okay, there's absolutely no reason to use my real name because I don't publish under it. So it's meaningless. It's just a way of harassing people. And so then on top of that, he's made his little buffoon page, and then he's taken my artwork and put it on his page instead of linking to my page. And, frankly, it's, artwork that I don't just publish and say, look, here it is. I actually put a little bit of a warning. It's, naked figure art, some of it. He just didn't care. And, he thinks this is, again, he's trying to do it to irritate me. And it's just like, well, the only part that irritates me is that you don't even have the integrity to ask somebody before you steal their content. I mean, you could at least ask. It's just pathetic. But it's certainly nothing I'm not proud of. I mean, I never called myself an artist, and I'm fairly good at some of it. Some paintings are better than others. I don't finish some of them. And the one he posted, I never finished it. One of my arms is pretty lame. But, the rest of it isn't bad. I mean, it's not finished. But it's not a bad painting, frankly. And I look pretty good. So fuck him. It's just so childish. I mean, there's no other word for this crap. I mean, these flat earth debunkers are just children. Well, he's not as flat earth debunking. He's just a bomb maker. He does videos about burning stuff and blowing stuff up. It's just so childish. So I'm surprised he doesn't have a exploding watermelon video. Because that's what they all resort to. But what a pathetic asshole. So anyway, obviously we're not getting along very well. Because he can't make a physics argument. I mean, all he does is spew these stupid insults. Go see a psychiatrist or take your medication, or it's all 1942 internet insults. That obviously to the professional interneters it can't mean anything. I mean, we're all way past giving a fuck about any of that nonsense. All right, so the simple thing is he did an experiment. So we'll just draw his experiment real quick. Little car, silly little fan on it. a car moves with an increasing velocity and over a distance. And so he claims that, oh, because it's following the Galilean rules, which is obviously what it's going to do distance-wise, that somehow it has this kinetic energy stuff because it moved in units of distance, not units of time, okay, based on the friction. So I would obviously argue that the friction means in the first unit of time it moved very little, and then it moved a little bit more, and then it moved a little bit more. So obviously it's a constantly changing velocity. And the point is that the easy test is just to crash it into a bigger object. So crash your little car in and have it be immersed inside of this thing, connected to it, Velcro or whatever, let it fly right in as clay or something, and you measure how much this moves, and it'll tell you how much energy this one had. Simple fact. Okay, and the fact is you'll conserve all of the MV, so all MV will be conserved, and you will lose at least half of the kinetic energy. So at best you'll lose half, and at worst you'll lose 99.9999999% in the case of a bullet. So that's the absolute truth. And you know, I've explained this over and over. So this all started, this is exactly the experiment that got me interested in this subject. I watched a physics girl video, whatever, 6 years ago, 7, and she was doing this preposterous example of the 5 mass, okay, going 10 velocity. All right, and then you just add another 5 mass to it. So now you make a 10 mass going 5 velocity. 10 mass, 5 velocity. All right, and you lose half the kinetic energy. Half the KE is gone. This pen is almost had it. Kind of mushy. Anyway, and so you're saying, so you conserve 100% of the momentum, right? And it's really close to 100% in these experiments. And then their argument was, she showed a picture of an egg getting hit by a bullet and a tomato exploding, and then she said, oh, it's deformation and heat. That's where the extra KE is. But somehow a whole bunch of shit flew off of this surface when they combined. Now you can see the experiment. None of that happens. Professor Lewin's done the experiment with an air track. There's no sparks. There's no bang. There's no catastrophe whatsoever. The two carts connect really easy, very smooth, and again, like 99% of the momentum is conserved. So you might have a little tiny bit of heat, little tiniest micro bit of a little bit of movement in the Velcro or something, tiny bit of loss, right? And they're claiming that no, half the energy's there, half of it. Yeah, and it's not there. And look, the simple argument is it can't be there. You can know it can't be because if you have energy going somewhere else, you have to use momentum to make that happen. You can't keep your momentum and knock down pins. You can't keep your momentum and put heat into the ground. You can't create friction, cause the ground to vibrate, and keep your momentum. You can't do both things. So there's no way you could logically understand that there could possibly be half the energy here, all right, and all the energy here. It can't be in both places. Duh. So it's impossible that there's any kinetic energy here because you would have to use momentum to make any energy there. You can't make heat without absorbing something's momentum. You can't make pieces fly off without absorbing something's momentum. And I really shouldn't have to make this video over and over again to intelligent people. I just can't believe I have to keep illustrating this and explaining how can you people defend this nonsense. I mean, it obviously doesn't work. Kinetic energy can't be collected. It can't do work. In the simplest experiments, it fails catastrophically. I really shouldn't have to keep doing this. All right, let's see if I have volume and stuff. Oh, you have to have a viewer for that. Yeah, okay, I have to see if somebody says something. Nobody said anything, okay. Alright, yeah, my camera's all fucked up. Yeah, I played the other guy's video, the whole video, and it just fucking didn't have the camera on. So that was really dumb. But whatever. Yeah. It's a one-man show. You know, I don't have people. I have to do everything. You know, everything. It's a funny life. Alright, so yeah, let's just do the bullet example. So Professor Lewin did this experiment. Alright, so the bullet goes in. Now, I'm not going to remember the exact numbers, but let's just say it's 2,000 joules of kinetic energy. And it's let's say it's 20 newtons, okay, of momentum. And all you collect in the pendulum is the 20 newtons. So that's all you get, 20 newtons. Alright. And it's less than that, frankly. So, you know, it's whatever. It's 18.3 newtons. Okay. Because obviously you do. The bullet goes in and it moves a bunch of clay in here. So it's obviously going to lose some, it's going to create some heat. No doubt about it. But their claim is that it's 1900 joules of heat. And not even close. Okay, it's just this. It's just the 2.7. Okay, that you're missing. Well, it's 1.7. Alright. That's all that's in there. Just this, whatever momentum's missing, that's what's in here. Because this is all momentum. The clay moving is momentum. You have taken it from the bullet and given it to the clay. So some of the momentum has been lost to moving the clay. Those are the rules. Okay. And the rest of the momentum moved the ballistic pendulum. And that's all there is. There's no other way to make this 1900 rational. Because it just doesn't happen. It can never be collected. How many times do I have to say that? It can never be collected. Alright, let's see what other version of this I can explain using. So 99.94% of the kinetic energy is lost in the experiment. Do you understand? 99.94%. You know, that's all of it, really. And it's just proof that there's this momentum. There's mv. There's no mv squared. It's not a thing. All right. So you think. Now, I'm not going to argue with, if you're this big an asshole, okay? I mean, the experiment's been done by every physics professor on the internet. So I'm not going to argue with you. It's not about what I think. It's about what actually fucking happens, asshole. They concede that it happens. Professor Lewin writes 99.94% of the kinetic energy is missing. It didn't get collected as linear motion. And then he claims it's heat. But they don't stick a thermometer in there. Okay, there's no evidence that it's heat. Ugh, you people are just so fucking lame. So again, I mean, it's just, you're just so fucking stupid. So again, the rocket example. What do you need as evidence? It's so glaring. If I calculate the kinetic energy of the exhaust, it's meaningless. If I shoot a bullet out of the spaceship this way, and then I shoot the recoiling gun, okay, in another experiment, right? The recoiling gun has 2 joules. That's it, of kinetic energy. That's all it has, okay? You know, and the bullet has 2,000. And guess what? The spaceship is going to move exactly the same for both objects because this is actually just 2 joules of momentum. That's all it has. The 2,000 is a preposterously made-up, exaggerated, nonsensical number that they just write. It has nothing to do with reality. So I can throw the bullet out of the spaceship, and all I'm going to get is the momentum in this direction. Newton's third law demands it as the truth. Newton's third law doesn't have anything to do with kinetic energy. It's basically, these are just laws about momentum. And they're trying to pervert them into having something to do with this nonsensical kinetic energy. And it doesn't fucking happen. So again, they could calculate this exhaust to be 25 million joules of thrust. But the only calculation that matters is the MV part before they squared it. It's only the 50 newtons, okay, that the spaceship will actually collect. You can't understand how that's just showing that this is nonsense. To talk about kinetic energy as being something that does work when in every single case it fails to do any work. Every single case. I mean, the hydraulic argument. You know, all you have to do is take a volume of water and reduce it, okay, by 50%, okay, half, and you've doubled the kinetic energy. Does that make any sense? I just turn the nozzle on the hose and I can make free kinetic energy? I mean, how can you make that make sense in your head? This scalar energy. There's supposed to be a certain amount of scalar energy in here. Well, how come I can just turn the nozzle and make more scalar energy? I mean, how can you believe a theory this lame and stupid and moronic? I mean, you know, so, you know, I'm getting back to the lever again. You know, like I said, there's so many ways to do the experiment. I really like the idea of just having a balance in, you know, suspended in the air, and then, you know, just have the two versions of the experiment. You know, the two masses at one distance and the one masses at two distances, and just prove that, you know, you just whack it and they're both going to end up spinning exactly the same with the same whack, because it's the same momentum. This mass spinning is the same exact momentum as this mass spinning. It's the same momentum. This is twice the velocity, and, you know, one mass. These are two masses at one velocity. It's the same exact momentum. It's the same force to push it. It's the same energy when it hits you. It can't be a different amount of energy. I mean, the Leibniz proposition, can you really believe, you know, that something with twice the momentum is going to hit an object and have the same force? I mean, that's what they're stating. You know, when you drop something in gravity, I drop a 1 mass 4 units of distance, I drop a 4 mass 1 unit of distance. They have exactly, you know, this has twice as much momentum. This is 4 times 1. This is 1 times 2 velocity. So this one has twice the momentum, 4. This one only has 2. And somehow you actually believe they're going to hit the ground and do the same impact energy. Then they're going to knock down the same number of bowling pins. So they have two different momentums, and yet you think they'll knock down the same number of bowling pins. They'll heat the ground the same amount, even though they have completely different momentums. You believe that shit. Damn, you're really dumb. All right, so let's see. Is there anything I can do? I was going to play a video, but, you know, the video he had on gravity was pretty lame, so it was no point. And so let me just see. I'll see if there's some other video that's worth playing, because, yeah, I mean, I could just go on forever, but is there any point? Yeah, is there any point? I guess I could read some. I mean, the comments are just so stupid. They almost don't, you know, I don't even, you know, it's almost like, oh, shit, why bother? You know, people are too stupid. All right, look, you just want me to block you, right? I'm not Terry Davies. I'm not the next that. I'm not whatever this shit is. Why don't you just go fuck yourself? You can't make an argument? Go fuck yourself. Talk your shit somewhere else, moron. You can't make a real argument or make a statement that's somehow coherent. Are you the next buddy butthole? Is that who you are? The next buddy butthole? I mean, fuck you. Stupid cunts. God. I mean, what lame, trolly nonsense. Grow the fuck up. Grow a dick and some balls and actually make a good argument. You fuckers. God, you're just so, they're all just such gutless weasels. All right, so this is an asshole who posts this 4 million-mile long comment because he has some kind of wacky theory of his own, and I'm supposed to argue his wacky physics. Well, I'm not going to do that, asshole. I'm arguing with conventional physics. Okay, I'm not arguing with fringe loonies with their own special wooey bullshit. All right, so fuck off with this crap. I don't give a fuck about your bullshit. And so his last paragraph, I'll read that. Can you explain why two gases mixing without changing pressure or volume still increase entropy? They don't increase anything called energy, asshole. They're not getting hotter. Are they, asshole? Are they getting colder? No, they're not, asshole. I mean, unless you have some reason to argue that they're, we don't have them in a reasonably insulated container. So what's the entropy part? You're just saying that because one's black and one's white and the black and white mixes, that somehow that's entropy. Well, that has nothing to do with energy entropy. That has nothing to do with energy going from being in big things, moving slow, and then dissipating into little tiny things that are harder to collect. That doesn't have anything to do with energy entropy. Okay? Entropy regarding mixing doesn't have a damn thing to do with it. All right, and obviously if it's under pressure, it means the little pieces are moving. So you can understand if they're moving constantly, that's creating the pressure, jackass. There can't be any pressure if they're not moving. They're obviously banging into each other, and that's why they're mixing. But the mixing doesn't mean anything. There's no physics theory that gives a fuck about whether it's mixed or not, okay? It doesn't change the energy of something. Mixing doesn't change its energy. You crazy, stupid fuck. I'm just so impatient. I'm just so sick of this shit. Why can you have high energy density? So high energy density usually means high velocity. High entropy, whatever that means. So how do you think, what do you think a neutron star is? I mean, do you really, you think it's not a more stable arrangement, or do you think it's a more unstable arrangement? I mean, I would argue it's like magnets, and you stack the magnets and it becomes a very stable relationship, not an unstable one. It becomes very stable. All right. Or how energy density, low entropy. So Bose-Einstein condensate. I mean, you can ask me a question, but what's the point? I don't concede the existence of anything called a Bose-Einstein condensate. This is all mushy physics, okay? You want to say that's real physics? I want to say bullshit, because you can't get a zero temperature. It's impossible. You'd have to escape gravity to have zero temperature. So, fuck you. All right, you say that objects in space have no entropy. So what are you talking about? An object can't have entropy. Shit. Entropy is a process, jackass. It's a condition that the universe is in. But you can't say a single object is in the condition. While appealing to visual intuitions. Now, fuck you, I do. About density and pressure. So fuck you some more. Prove it. Quote me, you butthole. I mean, this is just a waste of my goddamn time. You can't make a video. You can't draw anything. So just fuck off, okay? You're not going to make any arguments that mean anything to me. Link me to your fucking evidence of any of this shit, you fuck. All right, anyway. Also, your repeated invocation of compression and expansion cycles. Well, it's just kind of obvious that if a force was actually creating the external pressure and you actually did consume the force, that is, it got hotter as you made things smaller and smaller, then obviously the energy in the external universe has to be reduced because now you have more energy in the clumps. And if you break the clumps, well, then you have more energy in the external universe than you have in the clumps. So yeah, it's a cycle, fuckhead. Yeah, that's what I understand it to be. Why don't you just start with my simulation of charge? That's how it all begins, okay? It's a perfect illustration of charge, the creation of dipoles. And it shows you that there's the little bits of force and then the bits of matter. And that's all there is. There's no other universe. There's bits of force and two kinds of matter, electrons and protons. And that's all there is in this fucking universe, you fucking idiot. God damn it. Let's see. Jeez, I'm just so sick of this shit. And electrons don't sound right because electrons are quantum objects. See, amazing. Well, you think I believe that, you fucking idiot? I mean, do you really think I have any notion that fucking electrons and protons are some sort of quantum object that aren't in places and that are piled on top of each other in a singularity and are spooky, bullshitty things? I don't believe any of that crap. I think electrons are hard, discrete objects. They do not occupy the same space. They are never entangled. They are never superimposed. They're always in a place somewhere in space. I don't believe any of that crap, and I don't have any reason to believe it because there's no evidence demonstrating it. Stupid shit. And expansion cycles. Let's see. In electronics doesn't sound right because electrons and quantum objects described by wave functions. Yes, fuck you. They're not described by it. The double slit proves that they're not described by it. They say that it's just like water waves. Well, actually, if you look at the fucking experiment, moron, it's nothing like water waves. You think this is this? You think a wave went through my finger, you fucking idiot? This creates the same pattern as this, fuckhead. God damn. Anyway, they don't compress. Well, fuck you. Obviously, electrons compress, so obviously they haven't proven Maxwell wrong. Okay, obviously the force between them increases the closer they get to each other. Obviously that's elastic. That's called elasticity. When the force gets stronger and stronger, the closer two things get to each other. That's called elasticity, fuckhead. And that's how you store pressure, shit for brain. God, you're so fucking stupid. Anyway, they exist in probabilistic states. Yeah, fuck you, they don't. Okay, and entropy in quantum systems is formalized through the von Neumann entropy. Oh, fuck you all over the place. None of that's anything called evidence. You don't have a single experiment to show me it has a goddamn thing to do with any of this crap. So fuck you. I find the idea of shoving a microphone in my mouth repulsive. I don't know what the fuck you're talking about, but I will be expecting a response video. I don't even know what you're fucking talking about. You have all kinds of expectations. I think you ought to just shove off, fucker. I'm not terribly goddamn interested in your bullshit. So I'm just going to delete it. But, make a relevant argument against anything I've said. Quote what I say and then make an argument explaining how you have a piece of evidence that proves otherwise. Or shut the fuck up. Oh, God, I hate human beings. Alright, let's see what this... most adults are corrupt. Yes, that's true enough. Let's see. You remind me of another pseudoscientist guy just like you who used to make... Okay, so this is an idea that they're saying that this, butthole, Val Butthole, somehow he got insulted by a flat earther and he went to a guy's house in California and punched him in the face. And it was all on video. So that's the story this troll is telling. And then all these little fake sock accounts are saying, oh yeah, I remember that. Oh yeah, I remember that. Yeah. So the video disappeared. Right? So he committed an assault and battery right there on a guy's property. And somehow he still has a job as a professor at a college. That doesn't sound probable, especially now. I mean, with the zero tolerance and all that. I don't see how you could hit somebody first. Okay, you go to his door, you videotape him, say hello to the audience, and then you punch him in the face. That's the story. Does anybody think that could possibly be true? I don't think it could possibly be true. And clearly there's no videotape anywhere. So the whole thing is pretty disgusting that these trolls are defending batteries. Now, the fact that they think this weasel would scare me in a physical confrontation is funny as hell. Okay, I mean, I'm 6'1", and I've been in fights. I mean, I had to fight my whole adolescence was fights. So I've had like 45 black eyes, lots of cut lips. Now, no one ever broke my nose, but he has a nose that looks really breakable. But anyway, it's just ridiculous. I'm afraid of this weasel. Not even close. So I probably should just delete it. I mean, I was, I'm just saying, I mean, it's a fake story. It's got to be just a fake story because, frankly, the internet, nothing dies on the internet. It really doesn't. You can't make anything disappear, on purpose. Lots of stuff disappears because no one gives a shit. But I just mean stuff like this, that can't disappear. All right, so I'm just going to delete it. All right, by the way, are you showing emails that are not from me? Okay, we did that part. And he says, loser, loser, does all this loser crap, loser, loser. Let's see, you'll never cease to amaze me with your ability to make a fool of yourself in such a concise manner. So that's his response. I said, energy is not an observable quantity. It can only be calculated. So that's what he said. Energy isn't observable. It can only be calculated. Hilarious, right? But that's true because the scalar part is invisible and nonsensical. It doesn't have any function. It doesn't have any existence. They can't draw me a picture of how the scalar energy exists in the object. Where is it? What's it doing right now? Okay. So anyway, I said it's got to be the top 10 dumbest things said by a physicist. So I said momentum is easily observed. So it's easy to observe that something has a mass and it's moving at velocity. Why not let the cart stick to a ballistic pendulum? That will prove it doesn't have any kinetic energy, just momentum. So that was his. So his silly statement is his response to that argument. So instead of saying, "Yeah, well, okay, I can do that," and then I'll prove you wrong because I'll collect all those joules, he knows he won't collect any of them because he knows ballistic pendulums never collect the kinetic energy, ever. Okay. So it's just, so I said typical vacuous mush as a counter argument. Do a video about ballistic pendulums, I dare you. So that's the point. So any of these people, they should just do the experiment and then they can show everybody that yes, the kinetic energy is gone and I'm just going to make up a story. So even though you saw the two carts hit each other and barely even vibrate, barely, no issue at all, right? I'm going to claim most of the energy is gone. Somehow it just disappeared out of the objects. And it didn't use any momentum to make all of that disappearing happening. All that extra heat. No momentum was used. I mean, the fact that people think that's possible. You can make heat, but you don't have to use something's energy to make it. I can vibrate the ground without hitting the ground, without rubbing on it, without doing something to it. The ground will just vibrate. I'll touch it, okay, and it'll just do all kinds of stuff because it's magical energy. No, I can only give it energy I have. I have to give it energy I have. And the only form of that energy is mass and velocity. That's the only thing I can exchange. God. Oh yeah, that I did do that little clip where I did this to the camera. So that's the relativity argument. So they think photons don't travel straight lines and don't get to the other side of a spaceship in a straight line because of this. So they think I'm actually moving. They think they think I'm actually moving. I'm actually moving. I should write a song. Yeah. That's how dumb the physics is. I'd say I love how grouchy you are. I don't really love it. I'd frankly love to be, lounging somewhere, having grapes fed to me by, the appropriate humans. Anyway. Let's see. You are attacking a real scientist. Yeah, whose work is recognized and cited on Wikipedia. Hilarious. All right. So I finally said, what I don't believe is that moving the target makes the arrow fly crooked. So if they're shooting arrows and I move the target, it doesn't make the arrow fly funny. your belief that it does make you, it makes you silly. Yeah, so that's Andrea. Idiot, fucking retard. But anyway, let's see what else we got here. Let's see. So some comment about shit. Let's see. I have a question. What kind of turd are you? So he says the same joke twice. What kind of piece of shit are you? So the same exact nonsensical rubbish nonsense. So they can't counter argue anything. They can just throw insults, you know, and make claims. You know, electrons have quantum properties. Yeah, I say so. yeah, sure they do. All right, so I guess I might as well just block these assholes. It's a waste of my neurons to even read their rubbish. Okay. Let's see if we got anything else. I already answered you when asked the same question. So I still haven't... I thought the other guy, so it's the other physicist, the Icon Physics, that he's the one who says he believes in kinetic energy. And this asshole says he answered the question, but I can't find the answer anywhere. You know, I asked the simple question, do you believe it takes 25 times the fuel to move or spin something 5 times as fast? And I didn't find his answer anywhere. Alright, so the rest of this is getting old, so I won't bother with the rest of it. Alright, the other guy's arguing Newton again. And so he made this stupid statement that Newton said, clay, feathers, doesn't matter what you make the thing out of, it conserves the momentum. And obviously it's not conserved as linear motion. Newton never said that, so you're a liar. And an idiot. And a nut. And too stupid for words. You know, most physicists had the general idea, even Leibniz, okay, had the general idea that heat was motion, mv. It was momentum. I mean, you know, and especially Descartes certainly thought so. All right. Let's see. Yeah, that's enough. Yeah, enough of the comments. Let's say it's so bad. All right, let's see if the chatters have anything and such. Yeah, I really should find a video. Let's see, but you know, they're so rare. It's so hard to find a video where they actually make an assertion that's backed by anything called an experiment or anything called reasonable evidence. Yeah, hello isn't much. I can't do much with that. Alright, so I will go look for a video. Alright, let's see. I can science that. So yeah, in the video I made earlier, I did actually play I Can Science That. He did a video called Newton versus Einstein, but it was really boring and lame. Yeah, so it did, you know, and it all comes down to the precession of Mercury, and as I've pointed out so many times, you know, that can be understood as just saying that you can, all you have to do is have some disturbance in the sun, and any disturbance in the sun, like, you know, its center of mass being a little off center, would affect Mercury because it's so close. Mercury is so much closer to the sun than Venus or the Earth or Mars. But anyway, alright, so let's see if we can find something here that's interesting. I hate frickin' quizzes. Response to Peter Lane. Well, it's probably going to be Flat Earth. So he's got a ton of Flat Earth videos, which is disappointing. Because, you know, that's all just idiotic. Alright, corpuscular rays. Let's see what we can do with that. That might be interesting.
We need our money.
Alright, we've got to get through this stupid ad. Ads on videos, just physics videos. Just really bad idea. Alright, maybe I'll just post I'll post it as the whole frickin' browser. Alright. And turn on. Come on. Yeah, that worked. Okay. So I gotta check the sound. Right about there, I guess. And then I'll put this sound up. And let's see what happens.
Welcome to I Can Science That, where we do honest investigation of everyday science. I want to talk about corpuscular rays, because you hear this from time to time, that the rays coming from the sun, those beautiful things that they put on postcards and religious pamphlets, rays streaking down through the clouds. The divergent...
So this is how, obviously, historically, a lot of people did see that kind of idea and recognize that that's exactly what it kind of looks like, is that it's radiating. Yeah, radiating. But anyway, and then clearly once, you saw something like a radioactive decay, and you start seeing all this shit shooting out, it sort of makes the corpuscular theory seem awful sensible.
Divergence of those rays gives us a clue that the sun is local, is nearby, right behind the clouds. The heliocentric model, by
Alright, so he's doing some silly flat earth thing. I mean, what a waste.
contrast, says that the sun is millions of miles away. But how can that be if we see these divergent rays? Let's explore your thoughts about what...
Okay, so these rays, right, this is just, diffraction in an atmosphere, so it doesn't really represent anything seriously. But the idea that it is all kind of very straight-liney does say it certainly doesn't look anything like a wave. So, he's doing some flat earth argument when, frankly, this makes wave theory look kind of ridiculous. But a laser beam already does that. I mean, the whole wave theory should be just mockably, laughably silly, once you see a laser beam, and you blow smoke and you see the actual beam and all the photons are going in that tiny channel. How the fuck can that be a wave? It's just ridiculous.
What these divergent rays mean to you and what conclusions you can logically draw from them. So grab yourself a piece of paper and a pencil, a crayon, a writing tablet, anything you've got.
All right, so this probably isn't worth my time, but we'll see. Maybe he's going to get into diffraction, so that might be a little bit useful, but it doesn't look like it. No, it really doesn't.
Grab your paper and your pencil, rewind in your mind back to kindergarten mode, when you got out your crayons and you drew a scene with a sun in it. And you drew rays coming from the sun.
So, obviously, there's all ways that you can sit there and argue this shit. So, this video obviously is not going to go anywhere. So, we'll have to go find a better one. So, it's such a, again, it's an obvious subject. I mean, I just don't know how you people fell for all this crap. I mean, they draw this ridiculous, pattern of a photon where it's going up and down this way and it's going side to side this way. It has these different components doing all of this wobbly crap like a snake, like two snakes. And, it's just a silly. And then they don't even, so they do this silly drawing, and then on top of it being a silly drawing, okay, I guess it goes something like that, and then like that, and that this is the magnetic portion that's, a few thousand times weaker than the electrical portion, but anyway, it doesn't matter. They're this silly thing. And they don't tell you how many of these little things there are. They just draw this wavy line thing and say that's a photon. And, clearly the thing to understand is this photon has to have polarization. So that's the amplitude, they say, of this wobble. Okay, so it's, it's just, come on. Seriously? How is it doing any of that? What's the mechanics for it? It's just too ridiculous. And the simple answer is if you have bits of force going the speed of light, you could really understand that the wavelength is just the distance between the bits. So now radio waves make sense, because you're just saying there's a bunch of higher density bits here, where there's a whole bunch of them. And then there's a place where there's not a whole bunch, there's a lot less. And then there's a place where there's a whole bunch, and then there's a lot less. And then there's a place where a whole bunch. And that's what's hitting, that's what's leaving the antenna, and that's what the other antenna is receiving, is it's getting hit with a density. High density, low density, high density, low density. And that the thing called a photon is just this. And so if you're going to see a photon, like a visual photon, it has to hit the surface and cause electricity. And so it has to hit the surface, and I would argue its polarization just means it's they're all flying parallel, but they're not in the same, they're not following each other in the same line. So this is the polarization, and this is the frequency or wavelength. And it just makes so much sense, because you can just tighten it up. This is a red photon, this is a blue photon. And the whole argument would be is the blue one has more energy, not because it has more bits of energy. It doesn't really have more energy. It's just going to apply its energy over a shorter period of time. That's all. It's just a shorter period of time. So it's a tipping point argument. I can't tip this over. If I had this stick in my yard and I was going to throw baseballs at it, but each baseball doesn't have enough energy to tip it over, so it just does this. Obviously, if I throw the baseballs and I throw a baseball and I'm not going to tip it over. But if I throw a baseball while it's still moving, then I'll keep adding energy and I'll tip it over. So, high frequency photons can tip electrons. They can give them enough energy to leave the atom. But if I have the light slow, then the electron rebounds, because it's elastic. It's in an elastic environment. There's a bunch of other electrons. It's all seeing the other electrons, so it can't go closer to any of them. And if it goes closer, there's a repelling force that pushes them back again. So electrons are very elastic. So if I hit them and I let them move and then they come back again, well, then I can't kick them out of the atom, because I can't give them enough velocity to leave. I mean, it's such a good explanation. Ugh. But I don't know how you ever believed in this. I mean, I saw it first in grammar school, like 6th, 7th, 8th grade, I guess. 7th grade, something like that. And I was just like, what the fuck is that? How can you draw that on the board and tell me that has something to do with reality? What's controlling it? What are you talking about? How does this happen? How can you have something this complicated as your foundation? The foundation has to be simple, not complicated. Oh, it's so frustrating. All right, let me find a better video. That one sucked. All right. Let's see. It says, what is inertia? So I already played that one. That didn't go anywhere. So let's see. Maybe I should go way back and see how far back I can go. See if he did any better physics before he became a flat earth debunker. Oh, apparently not. Flat earth, flat earth, flat earth, flat earth. Oh god, it's just so fucking pathetic. They can't do better than this. Let's find silly nonsense to debunk. Let's see. Flat earth, flat earth. A little bit on airplanes, but who cares? Let's see. Solstice observation. Yeah, that's not too interesting. Let's see. How to triangulate. Yeah, well, don't really need to do that. That's not a debatable subject. Let's see. Relatively redux. Oh, Michelson, Morley. Yeah, no point in going over that again. So that was Newton versus Einstein, so that was 4 years ago. Let's see. What is the scientific method? Oh, please. It is ignore the facts and misdescribe everything. Do the Stern-Gerlach experiment where you're shooting atoms and say that you're really measuring electron spin. Yeah, that's really great science. Response to a response about density. I wonder what that's about. Let's see, density as a vector and F equals ma. Yeah, looks like all math. Well, we'll see. Maybe we'll have to come back to that. Is angular momentum conserved? Well, that's, that's the subject we were arguing before. There isn't really anything called angular momentum anyway. It's just momentum. Yeah, it's gravity number 4, the Cavendish experiment. Yeah, well, boring. Do you think the atmosphere works? I don't know what that is. Why is perspective? I don't know, 6 years ago. Let's see, moon tilt illusion. Yes, it's just all flat Earth. That's really disappointing. Let's see, mysterious moon. No. Alright, so we'll have to go with whatever it was called. See if I can find it again. Let's see. Angular momentum. No, we did angular momentum. Alright. Density as a vector. F equals ma. Alright, well, we can just play with the F equals ma crap because that's not Newton's formula. It's a pile of shit. Yeah, well, okay, let's try it.
Tonight I want to try something very different from what I usually do. Tonight I want to do a response video. What is this about? Now,
that's what I would like you to do. So I did that little 5 minutes of ballistic pendulum. Respond to that and explain how you can use momentum. Momentum can knock down pins and you can still have your momentum. You can use your momentum, give it away, and still have your money. You can give your money away and still have your money.
Do not do debunk videos. I don't like that whole angle of where we try to make each other look bad or make fun of each other. That is...
Oh, right. And 80% of your videos are, arguing with a flat earther and basically mocking the silliness of the propositions. But okay, they're better than others. But I did see a little bit of Photoshoppy stuff.
Is counterproductive. Instead, I think this is an opportunity to have a discussion, have some back and forth, questions and answers, and maybe we can start to understand each other and start...
Yeah, I know, but see, you really don't do that because I'm asking you quite desperately, explain to me why you believe it takes 25 times the fuel to move something 5 times as fast. I mean, where have you seen that in the real world?
Start to, make some real progress towards actual answers. Now, there's one YouTuber that I think seems like she's really interested in finding some truths, and that's what I want. I don't care what the answer is. I mean, I don't have a predetermined idea that the answer must be a certain way. I don't want to get into corners and argue our positions. Instead, I want to, maybe we're starting from different places, but I want to see if we can come together and find what reality really is.
Yeah, right, I know, but there's only one of this thing called reality, and there can't be contradictory explanations of it. It's either wave or particle. It's not wavical, it's not polar wave. Okay, it's not. It either is momentum or it is mv squared. Both of them can't be conserved whenever you transfer the energy from one mass into a different mass. ever you can't conserve it. Ever. I mean, clearly only one of these theories is right. You have to choose one. And if you're defending kinetic energy, I'm arguing you fail in every single experiment that you can contrive.
Yes. So without further ado, I'm going to play this video. This is Rachie and her thoughts about density and force, and I will be reacting to this in real time. I don't have anything prepared. This is just in real time. Let's try to address anything in here that I agree with. Let's flag those, and let's point out if there's anything that I think needs a deeper look. If there's any questions that Rachie asks, let's see if I have any answers. Okay.
So this is all kind of funny because, response videos were a routine thing 20 years ago. This wasn't some sort of magical event. I'm going to play somebody's video and point out where I think it's right and wrong. Yeah, I mean, that's what being on YouTube was for. I mean, I don't remember when I wasn't making response videos, frankly.
Okay, so let's watch this.
Okay, so I think most people would agree F equals m times a. Mass times acceleration equals force. In order for there to be a force, there must be mass times acceleration. And nothing moves without force, which again is mass times acceleration.
So obviously it's not what Newton said. Newton said the force essentially is momentum. It's completely, you could just switch the two things around because twice the force is twice the motion, 3 times the force is 3 times the motion. So they're equivalencies. There's no F equals ma, there's just F equals mv.
I think most people would agree with that.
Okay, most people would agree F equals mass times, force equals mass times acceleration. One of the very foundational principles of physics from Isaac Newton.
All right, so
Those
just
are
a lie
experiments
again.
we should be able to do.
It's just so obnoxious. I mean, Newton actually said the line, I don't know, Galileo might have said it first. If I saw further, it's because I was standing on the shoulders of giants. You people are stomping on Newton's shoulders, all right? It's not Newton's formula. It's not Newton's way of understanding it. He said understand it as F equals the change in your fucking momentum. And if you want the rate, like 9.8 meters per second, then you put it over time. So if you want to know the rate of a force, okay, because it's a constant force like gravity, well, then you put it over time. But if you want to know the net force is the net change in your momentum. That's Newton's formula. I mean, and I'm just saying, that's, you have no evidence that Newton said F equals ma because he didn't do it. So why do you keep saying he did that? He said that. He didn't say 9.8 meters per second squared or 32 feet per second squared. He didn't say that.
That's very fundamental. So yes, F equals ma. I love it.
Few problems I have. Number 1. Neil deGrasse Tyson says, and this is gravity. What is that?
Right. We're going to get into arguments about what is gravity and what is not gravity. I think we can agree the pencil falls, there's some kind of motion when I'm...
Yeah, it's collecting momentum. And so the more little atoms it has, the more momentum it collects. The fewer atoms it has, the less momentum it collects. When it hits the ground, you'll be able to tell how many atoms it had because that's going to be decided by the fact that the atoms are the sail. The atoms are the thing collecting the force. It's like they contain a bucket. And so each electron and proton is a bucket. And then they're all the same size buckets. And they're just sitting there collecting the rain. So as long as I don't have contact, as long as I don't touch the object or in some way interfere with its rate of collection, I don't drain the energy, I don't apply any friction or contact forces, it collects exactly the same in each little bucket. Each electron collects exactly the same. So the force is completely proportional to how much mass you have, because the mass is essentially how much sail you have if you were collecting wind.
I let go of it, it's in the downward direction. The word for that traditionally is gravity, but gravity carries with it baggage. People think different things about gravity when you use the word, and so I absolutely understand if we want to maybe set that word aside, or let's see where Rachel goes with this. But just because this happens,
it's a time-dependent force, okay? So the real argument is it's not about how much distance you fall. And obviously MGH doesn't work. So a meteor coming towards Earth, I can't use MGH anymore because it already has a velocity. And it's going to go through the gravity really fast. So it's going through the gravity faster than free fall, which means MGH won't work anymore. The amount of extra force I'll collect will be completely different because it went through the gravity really fast. The faster you go through the gravity, less gravity affects you because it's a time-dependent force. It's a huge, important fact, and none of you physicists will say it, and it's a fact that it's time-dependent. It's 9.8 meters per second of extra velocity per 1 second. God damn it. Yeah.
Does that mean mass attracts mass? Does that mean space-time is bending? I don't see that from this, right? We don't see any of that from a dropping pencil. What we do see and we agree on is that this thing accelerated downward. I think we'll hear Rachel say that it accelerated downward. Certainly it's at 0 speed. It gains some speed.
Right, and Galileo 400 years ago pointed out exactly how it does gain that. 1, 3, 5, 7, 9, because it's acquiring velocity. And so you keep adding just one little bit of acceleration per unit of time. And all the rest of your velocity is accrued. It's what you collected already.
Right? It gains some speed on the way down, so it must have accelerated. There's some kind of downward acceleration that took place.
That's mass times acceleration. So he's saying gravity is a force. Mass times acceleration.
Right, and it works exactly like a light bulb in reverse. And then you could take the light bulb in reverse and you could just say it's paint sprayer. So let's say I have a paint sprayer and it sprays, 180 degrees in all directions. It dissipates the paint. Well, the paint's going to spray at exactly the inverse square law. The little particles of paint are going to spread from each other in 2 vectors, 2 dimensions. That's the square. Okay. And the simple argument is the longer something's in the paint sprayer, the more paint it's going to get on its surface. It follows exactly that rule. And so you're claiming it's not a force, that it's not particles, that it's not quanta, that it's not clumps, that it's not all these things, and yet it behaves exactly as if it was. Exactly as if it was.
Acceleration.
Yeah.
Einstein says gravity is not a force. Therefore, Einstein is saying gravity is not mass times acceleration. Gravity is not a force, not mass times acceleration.
Okay, and very much as predicted, we're going to get into trouble where, and I hate that they do this, physics fans love to get out there and say gravity's not a force, right? They get out there and they and hey, if there's any physics fans that watch this, stop saying that. You're not helping. You're not helping.
All right, so, okay, why don't you make a video to Veritasium then? Why don't you make a video to all of the popular physicists on YouTube, because every single one of them is arguing that gravity's not a force. All of them are.
I have a whole soapbox about that, but that's for another story. For right now, we're watching a video from somebody who understands Newton's laws. And
see, look, your theory of gravity, Einstein's theory of gravity, can't be a force, because if it's a force, then it had to come from somewhere. And it carries with it a capacity to exchange its energy. So like all the other forces, you absorb the force and then you possess it and you carry it. So matter is a force carrier. And if gravity is giving matter motion, then it's carrying the force that gravity gave it. So, you can't even understand matter as a force carrier if you're going to say gravity doesn't follow those rules. Because, of course, it looks just like it does. It's not doing it any different way. So the simple answer is, well, it's a force we can't see. We can only see photons at a frequency, right? If the energy hits not in a frequency, we can't detect it. We can't just turn on a radio transceiver and collect every kind of frequency coming at the antenna. We have to tune to a frequency. We can't just collect the momentum. And the argument would be there's a ton of energy out there that isn't at a frequency. So it therefore doesn't create electricity and doesn't make something we call a photon. But it still hits an object constantly.
And understands that this pen accelerated. And she wants to see the force. F equals ma, where's the force? The force is gravity. That's understandable. And then you go and you hit them with, there's not a force. That is a long...
It's wrong to say you're conceding it is a force, and yet you have no speculation regarding how the force is manifest. How is it applied? What is it made out of? And the simple argument is, well, it's made out of light. It's made out of photons that are broken, pieces of a photon. That's what it's made out of. It's made out of bits of energy that the universe is full of.
High-level discussion for grad students and philosophers. That's not going to help people.
No, that's physics. Physics is explaining these things. So the fact that you still don't have a good explanation, that's your bad, okay? That's not somebody else's bad because they want one. Do you think there's not going to be a better theory? Do you think it's impossible for us to figure out what gravity is? Now, I'm arguing I've already figured it out, and I got the right answer. Okay? But the fact that you still seem confused, well, that's your problem. Okay? You can't imply that good science is just saying, fuck it, I don't want to bother. I won't even think about it. I won't draw it. I won't try to explain it. Well, 10 years ago, I started drawing it and trying to explain it. And after 10 years, I finally found a model that works.
Figure out what's going on here, right? For Raichi in particular, the fact that some physics fan says that was not a force doesn't mean it didn't accelerate downward, right? It did. You saw it, I saw it, they saw it, we all saw it. It accelerates downward, and going with F equals ma, that means there was an evident force. We saw a force. Einstein did not say pens don't drop, right? We all know the pens go.
All right, so again, Einstein was, a hypocrite because he changed the story a little. So later in life, he said, well, look, it's, you can't bend nothing. So obviously it's bent something, so there's probably an ether. So he just resorted to 200 or 300-year-old guesstimates and said, okay, let's just pretend there's something called an ether out there. And what are we going to make it out of? And how's it function? And what's it? And he's not going to bother answering any of those questions. He's just going to have some idea that, oh yeah, there's just this stuff that pushes,
go down. Newton said they do. Aristotle said they do. Einstein said they do. Anything that Einstein ever said does not in any way say that pens don't fall. We all know that pens fall. Okay? Okay.
All right, so I'm just saying that I don't really agree with this style of investigation where you just say, well, there was a murder. There's a gun and it's smoking and there's a body with a hole in it. I've done my job. Sorry, not even close.
Okay, next problem I have. This is a man. He has a dart. The dart has mass. He throws the dart. The dart now has mass and acceleration, so therefore there's force. The dart hits the dartboard, it stops. One of Newton's laws says an object will remain in motion unless acted upon by a force. So an object will remain in motion unless acted upon by a force. That must mean that there's a force here. In order for there to be a force, there must be mass times acceleration. There's no mass times acceleration here. There's mass here, but there's no acceleration here.
Yeah, but there really is. See, everything's under pressure. The only way that thing can stay together is there's a whole bunch of pressure built into it. So it's essentially elastic. It has electrons and protons in it, and they repel each other. And the fact is they're in geometric relationships where they are basically locked in those positions, where every electron essentially feels the pressure of all the other electrons, and likewise for the protons. So they're in elastic condition. So when you hit them, okay, they have a choice. They'll compress, and then they can throw the arrow back, or if that arrow hits with enough energy, you'll break electron atoms, the bonds between the atoms. You'll tear them apart. And so you're applying a force to them. They're absorbing the force and moving. So what's the problem?
Yeah, therefore there's no force here.
Hold on. The dart was moving, now the dart has stopped. That means there was an acceleration. There was a change in velocity. Acceleration is just changing velocity.
There you go. Yes, exactly. So why call it
was
acceleration?
moving,
Why don't you just call it
and
a
now
change
it's
in
not
velocity?
Moving, the dart.
That's all you should call it. Changing velocity. That's all it is. It's velocity. There's no such thing as acceleration. There's just changing velocity. Velocity is the function. There's no function of acceleration. There's just a function of changing a velocity.
Dart must have changed its velocity. There must have been an acceleration. There must have been a force.
All right, so obviously I don't agree with Newton that there was a counter force. Obviously this is just a case where something has momentum and it dissipates it into some other object. And so it leaves as heat in this case because the target isn't going anywhere. Even if it wobbles, it's still just heat. So it's just going to leave as molecules moving, and that's it. That's the total energy is essentially going to be put into the liquid of the atmosphere. So it's almost like a joule tank. And so all it is, you're just saying, I gave the arrow $10, and it gave $10 worth of heat to the joule tank.
I'm a little confused by the idea that it doesn't accelerate. This is something we should talk about deeper. I should be able to ask you follow-up questions, and that's what this is really about. Why do you say there's no acceleration? I could try to speed things along by making a guess.
Well, no, it accelerated out of the gun, but once it had a velocity, there's no acceleration. But it has the force, the mv. I don't know. That's again, it's Newton's saying force is the same thing as mv. It's just now the arrow is carrying the force. You put the force in, the arrow's carrying it, and now it's going to deposit it into the target.
I guess that you imagine the dart was moving and then it instantly stopped on impact with the board. But slow motion video will show that's not the case. The dart slows down very rapidly as the tip of the dart penetrates the cork. A rapid deceleration or a rapid acceleration. This is not instantaneous.
So there's no point in talking about it in any other terms than just a transfer. The energy will be transferred. The force, the pushers, will no longer be pushing the arrow, and instead are now going to be pushing cork and atmosphere and all kinds of other things, but they're not going to be pushing arrow anymore. Oh, it's just so obvious. But anyway, so no comments. Amazing. Nothing. People don't have anything to say? Wait, is the room closed or something? Let me see. Is there anybody in here? 3. I mean, that's just really bad. Well, anyway, who cares? I'm here. I'm playing the video, so I might as well finish the video. But, yeah, it's disappointing. But, life is disappointing. Lots of disappointments.
Yes. it's an acceleration. And so there must be a force exerted by the board upon the dart in order to slow its motion. We could measure that, right? We could set that up with some scales and things.
So again, this is sort of like a pressure argument, right? Is there really any point in saying that when you take high pressure and you move it into low pressure, that somehow there's a counter force? There really isn't. I mean, the Newton's cradle is a perfect example, right? The ball goes in, the ball flies out. You know, there's no opposite reaction anywhere. You know, there's just a transfer of the energy. It just transfers from one ball, goes right through all the other balls at the speed of sound in the steel, and the last ball pops out because it doesn't have another ball to hit. It doesn't have anything to transfer it to, so it keeps the energy because it's the last ball.
And throw things at scales and see if the weight registers on the scale when there's the impact with the dart. I think you'll find there is, right? If something impacts, we know that it tends to get pushed, and that's a force. So there is a force there. There is an acceleration there. Please come on back and explain to me if I was wrong about why you thought that. Why did you?
I mean, calling it an acceleration when it's a deceleration is a little bit playing games too. So obviously there's an exchange of the force. Like a bowling ball hitting a pin, all that's going to happen is the momentum, the force in the ball is now going to be in the pin. I mean, it's that obvious and simple. It exactly works out that way. Whatever momentum the pin has, the ball lost that much.
You think maybe there was no acceleration there? Or, I don't know. Let's hear from you on that.
But Newton's law says an object will remain in motion unless acted upon by force. Well, this didn't remain in motion, and there can't be a force, because if F equals m times a, there's no acceleration here, therefore there's no force here.
Again, there was an acceleration. Very clear.
I mean, this isn't a real argument of any kind. I mean, you're arguing with somebody who's got an agenda, obviously. I mean, this is a minutia, I mean, you obviously know that there's force now in the target, so obviously whatever force before the arrow hits the target's just sitting there, nothing's happening, and then you hit it, and there's all kinds of force in it. So, I mean, it's not that complicated. What are you arguing?
Very, very clear. Acceleration is the change in velocity. The velocity of the dart has changed. There was, just by the definition, an acceleration.
And it did not remain in motion. Okay, now people say density is not a vector, so obviously I'm going to try and prove that it is a vector. So
okay, that'll be interesting.
I came across videos which are showing me like the change in position, velocity, acceleration. Now I came across one video which says that displacement is a vector.
Displacement
So
is a vector.
displacement is the position final minus the position initial, or the change in position, which is the position final minus the position initial.
Right, and position doesn't mean anything because it's all time-dependent forces. Friction is a time-dependent force in gravity. Gravitational friction caused by gravity is obviously time-dependent. You get it in chunks of time, not chunks of distance.
So obviously I did Riley's experiment, and obviously the position final will be here, minus position initial, which would be down here. That is your vector, that is your displacement, and displacement is a vector. We know that we're changing the density, we changed it from here to here. Therefore it has a vector because the position changed, there was a change in position, so there's a vector. By changing the density there is a vector because it moves.
Okay, hold on there.
So this is just some sort of buoyancy argument. Something sinks in a fluid. So obviously it's the pressure differential that's creating the buoyancy. So, I mean, what's to argue? High pressure to low pressure.
Change in position is a vector. Yes. Yes. Change in position, definitely a vector.
There's nothing but vectors in the universe. So even this this is grammar school physics for me. So again, I've never been able to imagine anything but vectors. How could energy ever be transferred in any other way than through vectors? Obviously, you smash pool balls, they leave in vectors. I mean, there's a million metaphors for the fact that the energy always obeys these geometric rules. I hit it at an angle, angle of incidence, angle of reflection. I mean, it's all perfectly consistent. Vectors, vectors, vectors. There's no other thing but a vector of motion. There's no other kind of motion. Nothing moves in any other way than through a vector. Even water waves are vectors. The pressure, the molecules of water are either moving this way, and then they create high pressure as they're moving into more water. They're compressing the water. The water won't be compressed, so the pressure almost instantly increases. And the pressure, the only place that the pressure is less is up. So it goes up. I mean, it's all vectors. There's nothing else.
But you were pretty hand-wavy about how that meant density was a vector. Density is mass divided by volume. Mass is not a vector. Volume is not a vector. So from a mathematical point of view, I don't see how density became a vector. Now, you pointed out that...
Well, you could argue it's a vector of pressure. So in that sense, you could argue there's a vector of pressure. I mean, you can't increase density without increasing pressure.
Changing the density changed the position of the egg. And I absolutely agree. This is a really cool experiment, by the way. It's really good. People want to make fun of it, but it's a good experiment. And what it showed was that changing the density of the medium changed the buoyancy of the egg. That's absolutely correct. Don't let anybody tell you it isn't. That's absolutely, it happened. We all saw it, right? So does that mean density is a vector? No, it does not mean that. It means changing the density caused the egg to become buoyant, which is literally what that means, right? Changing the density affected the buoyancy of the egg. Yes, that doesn't make...
It just has to do with the density of the electrons and protons in the end. So the argument, I think, to be made is that you have more electrons and protons in a smaller amount of space. That will always, be heavier, in terms of when you mix it with other objects, because it has more pressure built into it, because it has more electrons and protons, and it has more, in a sense, force.
Density of vector, right? You're going to need to explain that in much greater detail. I think, now again, this is where I'm going to need you to respond. I think maybe it goes like this. It goes like the egg goes up and down, and the up and down is definitely a direction. That direction was caused by the density change. The density, therefore, has an innate direction to it. I think that's the logic, and that's not terrible logic. That's
Well, whatever. I just say yes. Obviously, it's just a matter of pressure, and the fact is that it gave it more velocity than it doesn't. Like anything else, it's elastic, and so it sprung further, and then it has to spring back, and then it has to wobble for a while to dissipate that extra energy.
That's a decent hypothesis. We could stick a pin in that. We could call that a hypothesis, and we can test for that. So let me propose that is a point we do not agree on, right? I say that density is absolutely not a vector. You say that you think maybe density has an inherent direction to it. I'm putting words in your mouth.
All right, so there's no point. I mean, obviously, all this stuff is moving. The individual atoms, the individual electrons and protons are doing all the moving. So, having this argument about the composite object doesn't make much sense because the composite object only moves when you move all of its parts.
Mouth here, right? So please do respond with specifics to correct me. Do you think that maybe density has an inherent direction to it? I would propose we do experiments to...
Let's just put it this way, okay? An elemental object can't have density. You don't have density when you combine a bunch of elemental objects. Maybe that's a better way to put it. So obviously the bunch of elemental objects can't have a specific vector because they're, generally speaking, going to be pushing on each other in all kinds of different directions. And they'll have a net velocity, but they'll have lots of other internal velocities.
Determine if that hypothesis is correct or not. Let me see if I can come up with an analogy. Right. I can drive my car. I'm going to drive my car from here down the street. That's a displacement, that's a direction and a magnitude, that's a vector. What made that happen? I'm going to say gasoline made that happen. The gasoline in my car.
Well, wouldn't it be better to say something like you're going to put a sail on your car and then blow it with wind? And then you could make the simple argument that the pressure does have a vector. Okay, the higher pressure of the wind. And so the higher density of the atmosphere. And that's being transferred to the car. So clearly, in that sense, the density creates a net vector. But the individual objects inside the wind have lots of turbulence and lots of other directions. The stuff inside the wind is moving in all kinds of directions. And there's just a net force. So it's like a school of fish. Every individual fish is moving a different way. But the net motion is, it has a net amount in a certain direction. It has more this way than that way. So the school moves this way.
Caused the car to displace. Now, I don't think we can honestly argue that that's not true. If you take the gasoline out, it's not going to happen, right? There are many other factors that went together with that gasoline to make that happen. And I think we'll also agree that gasoline does not have an inherent direction to it. Gasoline is not a vector. My application of force to the steering wheel.
But yes, it can, because it's almost the same thing as me blowing up a balloon. I'm creating a pressure, so we could argue you have the chemical pressure, and you can release it in any direction. And the catch is that, well, what's creating the pressure? Yeah, there's little atoms hitting the balloon from all locations, all directions. And you're only letting go one direction. You're letting go stuff that goes this way. And eventually, every molecule will eventually go that way and fall out the hole. You got a bunch of BBs, and you made a hole, and the BBs just keep bouncing off the surface. Well, eventually, all the BBs will leave. Because eventually, they'll all be going that way.
May have influenced the direction the car ended up going.
And the reason why the balloon goes the opposite way is because obviously none of the hits this way, you've taken away some percentage of the hits this way, are missing. And so now the balance doesn't exist. You let go stuff this way, which means it never hit the surface, which means the counterbalancing reflection never happened. And so obviously now you've created a net potential that way, because there's not the same number of hits this way, because you let the hitter go.
Right? I think that's obvious. We all get that. And I think that analogy applies to the egg in that way, where I think that the density change caused the egg to gain some buoyancy, and it went in a particular direction. But I think there's something else, kind of like the steering wheel of the car, there's something else going on that is providing that direction, the directional guidance. The steering wheel for the egg is somewhere here, and we haven't identified it, we haven't isolated it, but I think it's here. It's there somewhere. Okay.
Okay, so if we wanted to calculate.
So let's understand, if momentum is weight, you could sort of just understand that the more dense object actually collects more momentum, more weight from gravity. So it's automatically more pressure because it has a greater momentum that it's collecting from gravity.
Let change of position, we could do the position final minus the position initial, which again is just the same as displacement, which is a vector. If we wanted to find the velocity, we could do the change in position divided by the change in time, and that would give you meters per second. If we wanted to find the acceleration, we could do the change in velocity divided by the change in time, and that would give you meters per second squared. So that would give you the acceleration.
Hey, yeah, kudos right there. Yeah, absolutely. I agree completely. It was in my slides.
Meters per second squared. How? How is putting the change in the momentum over time create meters per second squared? Yeah, no, it doesn't.
I'm probably just going to edit that out now because I see we already agree. That's acceleration. Does bring me back to the dartboard and why the dartboard does not have acceleration when clearly it has a delta V, it has a delta T. So I think it's got an acceleration.
So obviously I did Riley's experiment, as I said. Worked out all the masses, took away the container mass, did the volumes, found out all the volumes and things, added it all up. Did what I needed to do.
Focus, but
then I used density equals mass divided by volume.
good.
And the density, obviously I found out that the egg was more dense than the water, but less dense than salt water, so that's why it sank in water but rose in salt water. Because of the density of the medium change. So then I came up with the equation again for.
There you go. I love it. Hey, that's the same equation I'm using. I put it the other way, but this is fine. This is great. I love seeing that. Excellent.
Of the vector. So the density of the medium minus the density of the object. If it's a negative number, it will fall. If it's a positive number, it will rise. So again, this gives you your vector because it tells you whether it.
Right, so again, we're just arguing about the density of the mass and heavier, that just makes them higher pressure in the end. So the higher the pressure, the more energy has been collected. There's probably a better way to explain buoyancy. Oh, yeah, there's how much empty space. So how much of the force of gravity is missing the object because of the empty space? That's the obvious answer. So the more density of the electrons and protons, the more gravity is going to be collected. It has to be more because you have the same volume of gravity, but you have more little bits for it to hit. There's more objects to hit, more sail. So more of the wind has to be collected.
It will rise or fall.
Very, very, very good. Good insight, good thinking, good experimental technique. When Sleeping Warrior does his version, I've only ever heard him talk about his relative density as dm divided by do, or do divided by dm, and that doesn't work. But what does work is subtracting them. What you are doing.
So obviously this 9.8 meters per second squared is nonsense. So again, why is the second squared? It's 9.8 meters per second per 1 second. That's the formula. This is not 9.8 meters per second over 1 second. It's just not the truth.
dm minus do will correctly predict not only whether something goes up or down, but how fast it does. And that's something you're about to get into, I think, right here.
This part
well
is
as
not
the
very interesting.
exaggerated.
Okay, so let's see if we get out of this density argument. It's just kind of mush. Let's see what he's doing here.
Of that, I don't know. Let's see here. Measure rate of falling. I don't know. Okay, let's see if we can find, here's one. Oh, I like this one a lot. I like this one a lot. So I would take a look at this video. We'll come back to that because they're going to look at a lot of the things you're interested in. Actually, this is a really good one. You can see I've already watched it. This one, they compare different objects based on size, density. I think those are the major factors. They're doing it in air, but they check different.
So air is essentially a fluid. So obviously the denser objects are going to travel through the air with less resistance. Blah, 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 blah.
Different sizes and different densities. They're all roughly round. Some of them, they're different shapes too. They drop like lemons and watermelons. So yeah, you should check that out and see what they did. But here's a really simple. Measuring G by dropping an object, and let's just look at it. Here we go. What does he do? I'll turn the audio off. What does he do? He just comes in here and drops. He's got a yardstick in the frame specifically to give things scale, so that he can now make a connection between how many pixels is how many.
Yeah, right. Well, it's better just to do it with a strobe, and then you'll see with the strobe a constant amount of time, and you'll get exactly what Galileo described. But whatever.
Meters, right? And then he drops the thing, and he goes in using a little like a video editing tool, basically, and he goes frame by frame through the video that he took and plots the points and sees how much displacement there is. From that displacement, we get a velocity. From the change in velocity, we get an acceleration. And he measures it. So what did he get? And you can do this yourself. And here's the plot that he made. I don't know, what did he get? What did he get? What did he get? Is the answer?
It doesn't look like 13579, which it should look like, but whatever.
In here somewhere? I mean, obviously he gets an answer at some point. Here we go. There's
That looks better.
there's the slope. There's this G, which is he going to say? I don't think I ever finished this video to see. There we are. Bink. Right there at the bottom here, he has measured 9.769, and that is his experimentally measured G acceleration. So, this is even kind of nice. He's got arrow.
I mean, obviously he just did the dots to match the fucking outcome. Duh.
Error bars on here. So you can see that it's plus or minus 0.187. So is that measured to within the tolerance of what you expected with the 9.81? Yeah, check that out. See if it is. Yeah, and this is something you absolutely can do yourself. It is this simple. Now,
why would I need to do something that's been done 4 billion times over the last 400 years?
There is air resistance involved, but you know, I've studied aerodynamics. The air resistance increases roughly with the square of velocity. So if your velocity is small, your air resistance is also small. So
yeah, but it's still a squared function. So in units of time, in units of velocity, it's still, this distance is 1, this distance is 16, It's a pretty big change. And the terminal velocity of a rubber ball or something is going to be like, what, 15 miles an hour?
Until that ball gets going, the resistance can be considered fairly small. So if you do it over a short distance, like this gentleman is doing here, you'll see a nice steady acceleration. And if you go over,
and again, this isn't broken down into units. It's this is like a tenth of a second or a hundredth of a second. I mean, or whatever.
a longer distance, like the other video I was showing here, and do please check this one out. A longer distance, you'll see that it starts off with an acceleration, and then the acceleration tapers off as it slows down because the increasing air resistance starts to slow it, slow the advance, and it'll settle into a constant speed at what we call the terminal velocity. Okay.
Yes, the pressure of the compressed atmosphere is the same 9.8 pounds. Okay, of pressure.
So that's that. Video evidence for how to do that. Please. Yeah, I mean, that's just what I did. It's not in a vacuum. Does it have to be in a vacuum? If you insist it must be in a vacuum, that's going to severely limit the number of experiments that people can do with it.
Right, so I don't know, why would people want to do it? We saw the hammer and the feather dropped on the moon. I mean, this isn't even close to a debatable subject.
There is, of course, the Brian Greene video that I think everyone has probably seen at this point. You should be able to use that one, I would think. Other than that, I would respectfully suggest that requiring that it be in a vacuum is...
I mean, again, other people have already done it in a vacuum. I mean, and there's some place where they had like a 60-foot vacuum tube. So, I mean, it's all been done already.
Extremely limiting. It means someone has a very tall vacuum tube. Although those are not unheard of. I can think of one person, one YouTuber who's got one right off the top of my head that you can maybe approach and say, hey, could you drop some objects in the tube and see. One thing that, is sort of a tangent at this point, but one thing I feel like people aren't aware of, but we had one in my high school, and this sort of answers it for me, let's see here, I'm going to say physics class, weight, feather in vacuum tube. Let's see about that. Yeah, these things. You see this? Here's the Brian Greene video. This thing right here, feather and coin in a vacuum. They sell these things. You can just buy these tubes. Here's another one. We had one in my high school. And what do we see? I don't know. Let's just watch one. What we see, here we go, is that when there's air in the tube, the metal ball falls very rapidly, but the feather gently floats down because of air resistance. But if the tube is evacuated, she's going to evacuate the tube. And now, here we go. Boink. And what we see is the feather just, boom, it just falls, right? So that, I think, really helps to answer, is this really true, that in a vacuum things really do all fall at the same rate? That wasn't a perfect vacuum in the tube. Maybe the feather is brushing against. He only had 1,500 feet, which only, for his 50-gram weight, only comes down to like one 1/100th of a gram, less than 1/100th of a gram. And his scale just isn't that precise. So the amount of wiggle just on the scale is more than that. And so you can't really rely on those numbers. So I don't even want to bother showing this to you. But, I live here in Southern California, and we have mountains, right? We have some mountains. Right up the road from me is Mount Wilson, which is 5,700 feet.
Who cares? I mean, obviously this is all completely undebatable physics. So, whatever. I have grown quite fatigued. So, anyway, that was a bit tedious. Oh, you weren't seeing any of it. Ha ha. Yeah. Oh, my bad. So, sorry. Oh, yeah, you saw it. Yeah, I just closed the window. That's why you're not seeing it, right? Yeah, it was there, right? Yeah, it was there. Okay. Well, you certainly wouldn't have missed anything. But anyway, so nobody's here tonight, so that's interesting. I mean, it's weird, but it's, I don't know. Thursday, right? Yeah, I don't know. Fridays aren't too good either. So I guess Thursdays and Fridays are don't bother wasting your time kind of nights. But anyway, it doesn't really matter, and such and so forth. The comments usually just irritate me anyway, so I think we'll say goodnight. Yep. Ugh, fuck. That was kind of just irritating. Yeah. Just it's just there's just no common conceptual ground. So it's really just arguing religion. So anyway, till the next time, and such and so forth and whatnot. Blah, 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 blah.